All right, day 3, number 9, draw lines to match each linear equation to its correct number of solutions. So let's just review how to figure out how to figure out which one of these match to. So with no solution, the variable terms match. But the constants don't. With infinitely many, every term matches. And then with only one solution, no term matches. No terms match. All right, so we'll go ahead and simplify all of these as much as we can. So what we're going to do first is we're going to, I looked crazy, we're going to distribute. Okay. All right, 5 times 4 is 20, and then 5 times negative x is negative 5x. Since I have these two terms, I can always just use keep, change, so I can actually have addition as well. So I'll keep the first number the same, change subtraction to addition, and the second number to its opposite. And then I can easily see that I have negative 5x plus 20 on both sides. Since every term matches, that's infinitely many solutions. I'm going to go ahead and go to the next color. All right, for the second one, same thing. I'm going to distribute on both sides. Distribute my negative 5 to all the terms inside my parentheses. So I'll have negative 20 plus 5x. I knew it was a plus because I'm doing negative 5 times negative x. And then I'm just writing down what I didn't touch. So then I'll look here and I see that the negative 20, I have a negative 20 on the left, positive 20 on the right. And I also have positive 5x and negative 20. If you notice, they're very close. They're opposites though. So really none of the terms match. Since that's the case, I'm only going to have one solution since none of the terms match. All right. And then my final one, the last one, I'm going to distribute first. Sorry, I used this color already, didn't even realize. Okay, use a different color. That was close to. Okay, that's good. All right, so I'm going to distribute my 5 to all my terms in my parentheses. 5 times 5 is 25. 5 times negative x is negative 5x equals negative 5x plus 20. Well, if you notice, same thing. We have minus, or we have subtraction, so we're going to do keep, change. So do keep, change with, with subtraction. Okay? All right, keep, change, keep the first number the same, change subtraction to addition, and the second number to its opposite. All right, so we notice we have the same variable term of negative 5x, but our constants 25 and 20 are different. So this has to be no solution at the bottom. All right, and that is number 9 for us. Moving on to number 10. Write a number in the box so that the equation will have the type of solutions or solutions shown. Remember, same thing as number 9. When we have no solution, it needs to be that the variable terms match, but the constants don't. Okay, write that on your paper. Okay, so the constants don't match, so they already have our variable terms matching. All you need to do is come up with a constant that's not the same thing as the constant on the left side. The constant on the left side is 5. I just need to pick any other number that is not 5. The one I'll go with is 2. Okay, so the key here is that it's any number not equal to 5. Okay, that's how you'll get your no solution here. All right, moving on to infinitely many. Infinitely many, every term matches. So we want the variable terms to match. We want the constants to match. So here they already have the variable terms matching their 1/3 x. And then we also want the 5 to match. So all we have to do is have our 5 here. Okay. All right, and then we have our last one. Only one solution. When we have one solution, no. Ew, now we got to change that one. No term matches. All right, it's really that. Let's fix this one for the one solution. The variable terms don't match. We can say that. And I'll fix that on the last one as well. Variable terms. I'm sorry about that. All right, so the variable terms don't match. Okay, so it's okay if you have these here because they'll end up just canceling each other out. But then you just have to make sure that the variables don't match so you can have your one solution. So let's just make this something super easy, simple. Doesn't really matter. I'll just do a 2. Oh, I already did a 2. Let's do a 4. Okay. So yes, I do apologize about getting confused about not saying that it was the variable terms. I wasn't even thinking about that. All right, and our number 11 was the solution to this equation. So we're going to distribute and then simplify. Distribute, simplify, combine, solve. Okay, let's distribute first on both sides. So 3 times x is 3x, 3 times -4 is -12, 2 times x is 2x, and 2 times -6 is -12. Then we'll add 12 to both sides. And again, since we see that the variable terms are not the same, it should be one solution here. All right, now that we see it's one solution, we'll have 3x equals 2x. Well, you can also see the only way that this is going to be a true statement is if we plug in, we know it's supposed to be one solution, so it can't be infinitely many. It also can't be no solution. If I plug in a 1 here for x, and I just mean I'm substituting, 3 times 1 is 3, but 2 times 1 is 2. That won't give me a true statement. It's false. So this one's out. But I can try 0. 3 times 0 and 2 times 0. Anything times 0 is 0, true statement. The only way that this equation works is if x equals 0. All right, Brian chose D as the correct answer. How did he get that answer? Well, Brian more than likely did what I did. And once he got here, he thought that it was a false statement. Let's not say he solved it once he simplified his equation. He assumed that it was a false statement. Which means no solution. But of course, we substituted to check our answers. That's how you know. That's how you can be sure that your answers are correct. Okay, you should always be able to back up what you're doing. All right, that's it for this one. Thank you.